Okay, we're going to look at proportionality and similarity. There's a huge part of the Euclidean geometry. There's a lot of things to know. But there's some things that we're missing that are really not that hard, that we should be able to get some marks for whenever we see it. One of them is this thing, if you see a triangle and a parallel line parallel to the base. Well, it means that you can break up the triangle into fractions proportionally. It means that BD here goes with DA the way that BE goes with EC, as long as DE is parallel to AC, and we call that the proportionality theorem. It's really useful. If you ever see these ABC is similar to DEF, well, you can match up their sides because they're proportional, because similar triangles are. Here's a couple of triangles, and they're proportional because their sides match up. Like, let's just try it here. First, just look at the letters and go AB goes with DE. There it is. It should equal BC going with EF. And that should equal the ones on the outside, AC going with DF. Now let's take a look at it. Let's take a look at BC. BC is 6 over EF is 4. Well, 6 over 4 is 3 over 2. Well, let's try AC. AC is 9, and DF is 6. And 9 over 6 is really 3 over 2. You see, if you make fractions out of the sides, and you get the same fraction, then we say the triangles are similar. And what happens is angle A must be equal to angle D. And angle B is equal to E, and C is equal to F. But if you see this, you can write these fractions down. That's what people could use and come up with some marks in these questions. Like, that's what I just explained over there. I said you can see this is proportional. And the other thing, what if they just said that BD, the ratio of BD to DA is equal to 3 over 2? Well, what you'd write down is BD is 3x, and DA is 2x. You don't know how long they are, but you know the ratio is. And that means that this must be a ratio of B to 3. And you write down 3y over 2y. You know that those ratios are the same. Now, you can, if you've done that, you can answer questions like this. What would the ratio of EC to BC is? Well, just go EC. Well, that looks like 2y. And then go to BC. Well, how long is that? That's 3 plus 2. It's 5y. So the ratio is 2 to 5. Now, this is a question, if you can just write in the ratios in the triangles, like 2x and 3x and 2x, 3y and 2y. If there's 3 triangles, you might have a 3z and a 2z. And then you can figure out other things if you've got this drawn in, if you can just get started. Now, let's take a look at this question here. It's a question from November 2018. They give us this big triangle. They don't tell us this is parallel. But so they say, okay, but they tell us a bunch of things. If you read this carefully, they tell you all those sides, but they tell you that ABCD is a parallelogram. So the first question is, explain why FC must be parallel to GH. Then we could use proportionality. We can't right now. Oh, it's a rectangle, which is a parallelogram. It means DC is parallel to AB. And if AB is the same as GH, then DC and FC must be parallel as well. So DC is parallel to AB because it's a rectangle, this parallel sides of a rectangle. And AB and GH and FC, then they have to be the same. But let's see how we're going to use proportionality now. I've made it in red so you can see these proportions. You see, AC goes with FG, the way that AC goes with CH. Why? Because there's a parallel line that's parallel to the base. That's the proportionality theorem. And then I'll just put in the numbers they give you. They say CH is 21, AF is 20, FG is 15. So just cross multiply a little bit. 20 times 21 divided by 15. My calculator tells me that AC is 28. Now they actually ask, find the length of DM. Well, this is a rectangle. You have to know a couple things, that diagonals bisect each other and that rectangular diagonals are equal. So that means this AC must be the same as DB. You'd have to know that. That'd be a thing to know. And if they cut each other in half, if they bisect each other, then if that whole thing is 28, that must be 14. So that's proportionality. And just if you see a parallel line going across the bottom, start playing with those fractions, and especially use that 3x over 2x, 3y over 2y. You can get started. You can get marks. You don't have to just leave. Okay.